In this session, I'll be explaining some of the quality attributes in the embedded system. Quality attributes are those that describes how well the system works, and it is also one of the quality deciding factors in an embedded system. There are two types of quality attributes. They are operational quality attributes and non-operational quality attributes. Operational quality attributes are associated with the execution of the system and are measurable. They are response, throughput, reliability, maintainability, security, and safety. On the other hand, non-operational quality attributes are related to the product of the system. That is, during production, there are few attributes that has to be taken care, and they are testability and debuggability, evolvability, portability, time to prototype and market, per unit, and total cost. Whatever may be the type of attributes, these attributes are to be documented carefully. The first type of operational attribute is response. We know that most of the embedded systems are basically designed and developed to be deployed outside an environment. These embedded systems are expected to react spontaneously and instantly to the changes happening in an environment. Having said this, there are two types of embedded system applications. They are real-time applications and non-real-time applications. Real-time applications are those that are designed to respond instantly to the changes in the environment. For example, in a commercialized aircraft, an embedded system is deployed to supply emergency oxygen mask to each passenger when the oxygen level becomes thin inside the cabin at certain altitude. Any delay in the response do cause problem to the passengers or sometimes even death. There are some applications that are not time critical and need not respond instantly. For example, electronic toys. Such type of applications are called as non-real-time applications. The second type of operational attribute is throughput. Throughput describes the efficiency of the system. That is, how fast the system works. This term is usually measured using some reference point called the benchmark. For example, suppose I want to grow two varieties of rice, VA and VB, in the same platform by dividing the platform into two equal parts and under the same conditions. It is observed that variety A consumes less water, less fertilizers, and gives maximum yield in shorter duration. On the other hand, variety B consumes more water, more fertilizers, and gives the same amount of yield as that of variety A, but in longer duration. By any means, farmers would prefer variety A than variety B, and hence we say variety A has set a benchmark or a reference value. Any other varieties could be called as a good yield if they break this benchmark or a reference value. The third type of attribute is reliability. Reliability is a measure of in what percentage we rely on the system. Let me take an example of banking sector. Generally, in our society, most of the people rely more on nationalized banks compared to the non-banking financial sectors because we believe that nationalized banks are more reliable, guaranteed, and chances of failure is less. That is, the percentage susceptibility of the system to failures is very less than the privatized banks. The reliability are defined in two terms: mean time between failures and mean time to repair. Mean time between failures gives the frequency of failures in terms of hours, weeks, and months. Mean time to repair specifies how long the system is allowed to be out of order following the failure. Because for an embedded system which are time critical, the failure should not be for a long time. Recovery and the repair should happen immediately within a minute or even microseconds. The other type of attribute is maintainability. Maintainability and reliability goes hand in hand. In today's world, we heavily depend on the internet for our day-to-day work. This is nothing but the reliability. At the same time, on an equal note, internet service providers also should maintain and provide the services without any interruption for 24/7. To provide a service for 24/7, the ISPs should periodically check their network or the cloud. And also, if there is any unexpected failure due to the breakdown in the cable or because of the server, the recovery has to be done immediately to resume back. Hence, maintainability also means availability and is defined in an ideal condition as empty BF divided by summation of empty BF and empty TR. The next type of attributes are security and safety. Security here means securing the data or protecting the data in terms of confidentiality, integrity, and availability. Confidentiality deals with the protection of data and applications from an unauthorized persons. Integrity means protecting the data and the applications from being modified from an unauthorized person. Availability means making the data available to the authorized users and not to the unauthorized users. On the other hand, safety deals with the possible damages that can happen to the operators or even to the public and as well as environment due to the breakdown in an embedded system, or might be due to the emission of radioactive signals or hazardous materials being used in the embedded products. So, safety analysis is a must to evaluate the anticipated damages and determine the best course of action to bring down the consequences of the damages to an acceptable level. So these are some of the operation quality attributes. Now we will look into non-operational quality attributes. First one is testing and debugging. Of course, testing has to be done in order to ensure that the hardware and the firmware works properly as our expectation. There should not be any delay in debugging the errors that has been encountered during testing. Testing and debugging has to be done very carefully using testing and the debugging techniques before the product is released to the market. The second attribute is evolvability. Your product should be compatible to accept the changes happening in the technological world. To sustain in the market, updation is very much necessary in the product that you have designed and developed. The next type of attribute is portability. Portability can be taught in two senses. Portability can be moving the device from one place to another. To do so, the device should be small, weightless, and must have long battery lifetime and must be capable of withstanding any harsh climatic conditions so that it can be deployed anywhere on the earth. Portability also means the program that you develop should be able to run on any platform or operating system and even in any target processors like 8086 and ARM processor and even for the higher end processors. The next type of attribute is time to prototype and market. This is a very important attribute because it decides the fate of the product. Every product in any field should go through the following phases. The first phase is conceptualization that emphasizes on your idea and methodology, followed by design and development, followed by testing, and then releasing the prototype of the product to the market, taking the feedback from the customers, and then reframing or repairing if required, and then going for the mass production that will be finally released to the market. All this process should not take a long time. Otherwise, it loses its market if any peer companies come up with the same product with higher end technologies. So, time to market is very important criteria and releasing the prototype at the right time is very important in today's world. The next type of attribute is per unit cost and total cost. Any company that deals with the embedded system products have two important aspects for consideration: market analysis and cost benefit ratio. Since embedded system products are highly sensitive to commercial aspects, one has to do the market analysis before going for mass production. And also, cost benefit ratio analysis needs to be done before launching the product, because these two factors would decide the fate of the product in the market. So these are some of the non-operational attributes in the embedded system. Before considering the above attributes in designing and developing an embedded system, it is very important to understand the life cycle of the product. Analysis of the product life cycle can be very well done using the graph with the key parameters, revenue, and the time. We divide the product life cycles into 5 phases: product development, product introduction, growth, product maturity, and product retirement. In the first phase, that is, in the design and the development phase, there is only investment and no returns. Once the product is ready, it is launched into the market. Initially, in the product introduction phase, the sales and the revenue will be very low. If there is no much competitors with the same product and with the high-end technology, sales and revenue will tremendously increases with time in the growth phase. During the maturity phase, the growth, sales, and as well as revenue will be in the steady state. And during the course of this phase, the product sale may reaches to the peak. And finally, the product enters into the decline phase or product retirement phase, where the sales drops down drastically and the revenue declines, because during this course of time, a similar product would have been launched by some other competitors with a high-end technology. And as a result, this product becomes obsolete and the company will announce its product withdrawal or discontinue in its production. So, understanding the product life cycle is very important before deciding on the quality attributes for designing and developing the embedded system. Thank you.